Have you ever stopped, maybe paused to think about how you can really trust scientific results?
Mm.
Whether it's checking the food you eat is safe or calibrating some super precise instrument or even, say, a medical test result.
Right, things you rely on every day.
Exactly. There's this like quiet but really powerful framework working behind the scenes. It's all about ensuring that trust.
Yeah, it often goes unnoticed.
Okay, so let's unpack this a bit. Today, we're doing a deep dive into ISO IE Session 14025.2017.
Yep.
That's the big one, the international standard that defines the general requirements for the competence of testing and calibration labs.
And what's really fascinating here, I think, is how it's designed not just for competence, but to make sure labs generate results that are genuinely valid
Valid, okay.
and operate a quality system that's, internationally recognized. So our mission today is really to explore what that means for you and for the world around us.
Great. So when we talk about a gold standard like this one, ISO IEC 17025, what's its core purpose? Who is it really for?
Well, at its heart, it's the blueprint, essentially. It helps a lab show it's technically competent, that its results are valid.
Right.
And crucially, it helps them operate a robust quality management system, a QMS.
QMS, I got it.
That's basically the framework, the policies, processes, procedures, all designed to ensure consistent, high-quality work. And it applies universally.
Universally. So any lab.
Any lab. Doesn't matter if it's an internal department in some huge company or a lab working for just one client or a completely independent third-party lab.
Huh. Size doesn't matter.
Nope. Size, scope, number of people. The core principles are the same for everyone.
Yeah.
First party, second party, third party labs, all included.
So it's really not just about like the technical skill involved in doing the test correctly.
No, not just that.
It's also about how the whole lab is managed, how it's run.
Precisely. That's the key. Its scope covers both things. The technical competence part, can they actually do the specific tests or calibrations accurately?
Okay.
And the management system requirements is the lab run consistently and reliably. And this whole approach, this dual focus, it applies whether the lab is using standard methods, off-the-shelf ones,
Right.
or non-standard methods, maybe adaptive ones, or even methods they've developed themselves in-house.
Interesting. So even if they invent a new test.
Yes, as long as it's properly validated, of course. It's all about building that trust from the ground up in every single step.
Now, you mentioned it's the 2017 version we're talking about. That implies it changed, it evolved.
Well, it did, yeah.
And I hear that 2017 revision was pretty significant. What were the really big updates, and I guess why were they needed? What problems were they solving?
That's a great point because, yes, 2017 was a major shift. A few key things stand out.
Okay.
First, and maybe most importantly, they integrated risk-based thinking right across the board into all processes.
Risk-based thinking, what does that mean in practice?
It means labs now have to proactively identify risks, things that could go wrong and affect the results, and plan how to mitigate them. It's not just about reacting to problems.
So being proactive rather than reactive.
Exactly. Think about maybe planning for a potential power surge that could affect sensitive equipment or a rare chemical contamination. You build safeguards in before it happens.
That makes sense. Turning weaknesses into strengths almost.
Sort of, yeah. It makes the whole system more robust. Second big change, a much greater focus on information technology.
Like computers and software?
Yep. Recognizing how vital things like LIMS laboratory information management systems are now. Managing data, workflows, it's all digital for many labs.
Yeah, sure, that tracks.
What else? Third, it really embraced a process approach. This means looking at activities as interconnected processes, which helps align it better with ISO 9001.
ISO 9001, that's the broader quality management standard.
That's the one. So this alignment makes it easier for labs that might want or need both certifications. It also just improved the structure, made it clear.
Okay.
And finally, and this one's maybe a bit more subtle but really important, more emphasis on decision rules related to statements of conformity.
Well, okay. Decision rules related to statements of conformity. That sounds technical. Break that down for us.
Yeah, it does sound a bit dense. But it's crucial. It means labs have to be really clear and upfront about how they decide if a result actually meets a requirement or passes a limit.
Especially when there's uncertainty. Like if the result is right on the edge?
Exactly. Measurement always has some uncertainty. So if your result is, say, 9.9 and the limit is 10, do you pass or fail?
Good question.
The standard now pushes labs to define and document clear rules for making that call, taking the uncertainty into account. It reduces ambiguity, makes the pass or fail much more defensible.
Right, so everyone knows the rules of the game beforehand. Less room for subjective calls.
Precisely. Consistency and transparency in those critical judgments.
Okay, those 2017 updates definitely sound like they strengthen the standard quite a bit. Now, to really grasp how all this works together, how does the standard actually lay itself out? What are the main sections, the clauses? Is there a logic to the structure?
There absolutely is. It's structured very logically, broken down into distinct clauses, each tackling a critical piece of the puzzle. Think of it like building blocks.
Okay.
Clause 4 covers general requirements. This is the foundation: impartiality, confidentiality. Basically, ensuring the lab operates ethically and without bias, like a neutral referee.
Got it. The ethical groundwork.
The Clause 5 is structural requirements. This defines the lab itself, its legal status, organization, roles, responsibilities, making sure it has the right structure and independence if needed.
Makes sense. Structure follows principles.
Clause 6 is all about resource requirements. This is the stuff you need: competent people, suitable facilities, properly working and calibrated equipment, traceability of measurements, how you handle external providers.
They're tangible things and the people.
Exactly. Then Clause 7 dives into the process requirements. This is the how-to. It covers test and calibration methods, how you handle samples, estimating measurement uncertainty, ensuring quality control, reporting the results clearly. This is the core operational part.
Right. The actual work being done.
And finally, Clause 8 deals with management system requirements. This is where it outlines how the lab establishes and maintains that overarching QMS we talked about earlier. And importantly, it offers two options here.
Okay. So it flows logically. Ethics, structure, resources, process, and then the management system holding it all together.
That's a perfect summary. It's designed as a complete, interconnected system. Every part supports the goal of reliable, trustworthy results.
That level of detail is, well, it's impressive. But let's get practical. For a lab to actually do all this, to comply, what kind of documents, what kind of records are we talking about? Is it a mountain of paperwork?
It can seem like a lot, but think of these documents as the lab's operational memory, its DNA. They ensure consistency, traceability, and proof of competence.
Okay, so what are some common examples?
Well, you typically see a quality manual. It's technically optional now under the 2017 version, but highly recommended. It's like the lab's constitution outlining its quality policy, objectives, scope, how the system is structured.
The big picture document.
Right. Then you have the crucial standard operating procedures, or SOPs. These are the detailed step-by-step instructions for everything: how to run this specific test, how to handle that piece of equipment, how to analyze the data. Ensures everyone does it the same way, every time.
The instruction manuals for everything.
Exactly. Beyond that, you need meticulous personnel records, proof of qualifications, training, ongoing competence checks.
Makes sense. Need the right people.
Absolutely. And equipment records, calibration certificates, maintenance logs, who used it when, proof the tools are up to scratch.
Right.
You also need documented test and calibration methods, naturally, and proof they've been validated, shown to work correctly, including how you calculate uncertainty.
Uncertainty again.
It's key. Then there are records showing the system is working and improving. Things like internal audit reports, management review meeting minutes, records of corrective actions when something goes wrong.
So proof of continuous improvement.
Yes, and proof you handle problems properly. And finally, records related to the customer, how requests are handled, dealing with complaints, getting feedback. It's about creating that transparent, auditable trail of competence.
It sounds incredibly thorough. Now, you mentioned back in Clause 8 there are two options for the management system. Why the choice? What's the difference between option A and option B?
Yeah, this is an interesting bit of flexibility built into this standard. It basically acknowledges that labs might already have quality systems in place.
Okay.
So option A is kind of the direct implementation route. The lab sets up its management system following the specific requirements laid out right there in Clause 8 of 17025.
So it builds the QMS according to 17025's instructions.
Exactly. This is often the path for labs that don't already have, say, an ISO 9001 certification. It's self-contained within 17025.
And option B?
Option B is designed for labs that already operate a management system that conforms to ISO 9001.
So they have that broader QMS already.
Right. Option B lets them demonstrate that their existing ISO 9001 system, when combined with meeting the technical competence requirements of Clauses 4 through 7 of 17025, fulfills the standard.
So they don't have to build a completely separate system just for the lab.
Precisely. It allows them to integrate. If their ISO 9001 system already covers things like document control, internal audits, corrective actions, They don't need to duplicate that specifically for 17025. It's much more efficient.
That sounds very practical. So option A, if you're starting fresh, you're focused solely on 17025. Option B, if you're already living in the ISO 9001 world.
That's a good way to put it. It avoids unnecessary duplication and leverages existing systems, which is smart. It really provides a significant efficiency gain for those labs.
Okay, this really paints a picture of 17025 as this detailed, robust standard. But let's zoom out a bit. How does it fit into the bigger landscape of international standards? Is it a lone wolf or part of a pack?
Oh, definitely part of a pack. A very well-coordinated pack, I'd say. It's interconnected with several other key standards.
Like which ones?
Well, we've mentioned ISO 9001 quite a bit. That's the foundation for quality management systems. And 17025 aligns with this process approach.
Right.
Then there's ISO 189. This one is super important for medical labs. It's specifically for them. And it actually builds directly on, it's derived from ISO IEC 18025, but adds requirements specific to medical testing.
Ah, a specialized version.
Exactly. You also have standards like ISO 19020 for inspection bodies. Similar principles, but focused on inspection activities, not testing or calibration.
Okay.
And then there's ISO 17011. This one is interesting. It lays out the requirements for the accreditation bodies themselves, the organizations that actually assess and accredit the labs to 17025.
So a standard for the standard checkers.
Precisely. And ISO 1911 provides guidance on auditing management systems, which is relevant for internal audits and the accreditation audits. So it's a whole ecosystem working together.
Wow, quite the web. Which brings me to the next logical question. Who are these accreditation bodies? Who actually comes in and says, yep, this lab meets ISO IEC 17025?
Great question. That's the crucial step of accreditation. It's done by independent, recognized accreditation bodies, or ABs.
Okay.
And these ABs operate nationally or regionally. For example, you have UKIs in the UK, DAX in Germany, IAS in the US, EIAC in the Emirates, GAC in the Gulf region, PNISC in Pakistan. There are many around the world.
So different bodies in different places. How do we know they're all applying the standard the same way?
That's where the magic of mutual recognition arrangements, or MRAs, comes in. Many of these accreditation bodies are signatories to international agreements, like those managed by ILAT, the International Laboratory Accreditation Cooperation.
ILAC-MRA, what does that do?
It means that the accreditation granted by one signatory body is recognized as equivalent by all the other signatory bodies.
Ah, so if a lab gets accredited by UKs?
Then that accreditation should, in principle, be accepted by customers and regulators in countries where DACs or IS or other MRA signatories operate. It creates a global passport for accredited results.
That's huge. It builds that international trust you mentioned earlier.
Exactly. It underpins global trade and confidence. It's a seamless web of trust, ideally transcending borders.
We've really dug into the mechanics, the structure, the connections, but let's bring it right back home. What does all this technical stuff, ISO IEC 12025, actually mean for you, our listener? Why should someone outside a lab care?
Because this standard, fundamentally, is the invisible shield ensuring the reliability of so many things you encounter every single day, often without a second thought.
Like what? Give us some examples.
Okay, well, think about the quality report for your tap water, or the calibration of the pressure gauge on an industrial boiler that prevents accidents.
Right.
Or the safety testing on a new medicine before it reaches the pharmacy. Or even the nutritional information and fat content, the protein on your food packaging.
Huh. All that relies on testing.
It all relies on testing and calibration. And the confidence you have, or should have, in those results often traces directly back to whether the lab doing the work is accredited to ISO IEC 17025.
So when you see that accreditation mark,
it's not just a logo. It's a powerful signal. It says, look, every critical part of this process, the equipment, the methods, the people, the quality checks, the reporting, has been independently verified against a tough international benchmark.
verified by one of those ABs we talked about.
Exactly. It means the results aren't just a guess. They're backed by a system designed for scientific certainty. You can rely on them for your health, your safety, your business decisions. It's really the bedrock of trust in measurement and testing in our modern world.
So wrapping this up, we've really unpacked ISO IE's 17005. It's clearly way more than just a document. It's what turns a lab into this globally trusted source of accurate information.
Yeah, it's more than just rules. It's truly a framework that supports competence and scientific results everywhere. It's about knowing that when you see that lab report, you can genuinely trust what it says.
It really makes you think, doesn't it? How many decisions we make, big and small, from the safety of things we buy to critical measurements that keep things running, they all depend on this unseen scientific certainty. this quiet guarantee provided by standards like 17025.
Yes.
And it kind of makes you wonder, what other hidden systems, what other quiet frameworks like this one are working behind the scenes right now, ensuring the quality and trustworthiness of the world around us every single day?